Guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, that is the BYJU'S Exam Prep. Welcome to the BYJU'S Exam Prep. Yes guys. All right. Hi, good evening Jaideep, Manasvi, Jeshroon. Very good evening all. Very good evening. Welcome to the session. Yes. Chalo. Just a second. Chalo dear. So let's get moving on. Welcome once again to the GATE Champion Series. Yes, this is the GATE Champion Series. Let me again remind you that in this GATE Champion Series, we are having the more than 500 technical questions live of your branch. Yes, and more than 500 question collection for your entire technical subject means it's like a workbook. It's a GATE workbook that is being discussed live on the BYJU'S Exam Prep GATE in ECE YouTube English channel. Okay, and this is the EMT currently going on, and today we are going to discuss the questions of the Waveguides. Good evening Sai Pani, Dreamer, Karan Gupta. Very good evening all. Okay. So let's get started discussing the questions based on the Waveguides. And in case somebody new to my session, let me start by a brief introduction about me. This is your mentor and educator Rakesh, and I have secured All India rank 9th in the GATE and completed my masters from the Indian Institute of Science, Bangalore. Right, and it's been more than 12 years, and this is my major area of expertise, which I have been dealing for more than 12 years now. Right. Yes guys, so Sunday is round the corner. Yes, tomorrow, Sunday. Yes, at 12:30 p.m. we bring to you a special mega workshop on strategy to secure AIR under 100 in GATE 24. Time is there, considerable time is there. Easily you can secure AIR under 100 or little bit more efforts, even AIR under 10 single digit rank. But how, what should be the proper procedure? What should be the do's and don'ts? On this session we are going to discuss, and this session is going to happen on the BYJU'S Exam Prep app. Yes, the app is available on the Google Play Store. You can download the app and register for this special event immediately, and you can catch me tomorrow live at 12:30 p.m. Okay, now guys, here comes the first question for the day. A waveguide has a cutoff wave, and starting with a very simple concept, this waveguide has a cutoff wavelength of 2 centimeter. Okay, which of the following signals will not be passed? Will not be passed by the waveguide. So cutoff wavelength is given to you. So what is the cutoff frequency? So we know that lambda is C by F, or F is equal to C by lambda. So what is the cutoff? What is the cutoff frequency? C, 3 into 10 power 8, because there is nothing mentioned. We'll automatically assume that the waveguide is air filled, divided by its wavelength, that is 2 into 10 power minus 2. So this is 1.5, 10 raised to the power 10. In terms of gigahertz, the cutoff frequency is 15 into 10 power 9, that is gigahertz. So there is a waveguide having the cutoff frequency of 15 gigahertz, and we must know that waveguides are as a high pass filters. Waveguides behave as high pass filters, right? So which of the signal will not be passed? Which are less than 15, which are having the signal frequency less than 15 gigahertz. F less than FC, attenuation, right? For those signals which are having the frequency greater than FC, they propagate. Okay, so कौन सा pass नहीं होगा? 12 is the signal that is not going to be passed. Now such question I can convert into MSQ question. Which of the signals will be passed, will be propagated? So these three can be propagated. They are having the frequency greater than 15. So these three can be propagated, right? And then it becomes the MSQ type question. Okay, chalo. Next one. A 2 centimeter by 3 centimeter rectangular waveguide is filled with a dielectric material with a dielectric constant होना चाहिए, with a dielectric constant of 6. Okay, dielectric material, अच्छा वो repeat हो गया है word, with a dielectric constant of with a epsilon r equal to 6. The waveguide is operated at 20 gigahertz with TM11 mode, what is the cutoff frequency? There are multiple questions based on this. One by one, let us discuss. What is the cutoff frequency? Now, with this all questions, now we will revise all important formula of rectangular waveguides. I will also take up the questions of circular waveguides. Okay, the first important formula, whether it is the TE, MN or TMMN modes, what is the cutoff frequency given by? The cutoff frequency is given by the formula U dash by 2 under root of M by A whole square plus N by B whole square. That is a very, very important cutoff frequency. Many questions can be just on the cutoff frequency only. Here, what is the U dash, guys? Now, whenever in the waveguide terminology, I write any formula in form dash, in the form of dash, U dash means it is the speed. U means speed. It is the speed formula. If there was the open dielectric, forget the waveguide. The signal is propagating in the waveguide. The waveguide is filled with the dielectric. But suppose that dielectric was open medium. Then in that open medium, what is the speed formula? So what is the speed of wave formula in an open dielectric medium? That we have studied in the previous class also, wave propagation class also. That is given by the formula 1 upon root mu epsilon. 1 upon root mu epsilon. So यहाँ पे कितना हो जाएगा, guys? Here, what is going to be that formula? U dash 1 upon root mu epsilon. Nothing mentioned about mu, so we'll take it as non-magnetic. Mu will be mu naught, and epsilon are given as 6. The total epsilon will be 6 epsilon naught. It is 6 epsilon naught. Okay. Right. 1 upon root mu naught epsilon naught. That is 3 into 10 power 8 divided by under root 6. We have learned in the previous classes also. 1 upon root mu naught epsilon naught. That is the speed of light formula. 3 into 10 power 8 C. Okay. Divided by root 6. So, ye kitna aa gaya? Let us just quickly complete the calculations. 1.25. So U dash is 1.25 into 10 power 8 meter per second. Now dear, what is the cutoff frequency? The question is on TM11. Okay, TM11, the cutoff frequency is U dash by 2 root over of 1 by A whole square plus 1 by B whole square. Let us place down the values. Okay. So what is the cutoff frequency? The cutoff frequency is now 1.25 into 10 raised to the power 8 divided by 2 square root of 1 by A whole square, where A, now 2 by 3 centimeter. See, actually 1 by A, 1 by B, both terms are symmetric. But what is A, what is B? What is A, what is B? The broader dimension is by default the A and the narrower direction is the B. Right. This is the front cross section of a rectangular waveguide where base is always greater than the height for the practical waveguides, having an ideal aspect ratio of 2. Ideal, the desirable aspect ratio is 2 or somewhere around 2. Right. Hi, good evening Karan, Janvi, good evening Jaideep. Okay. So A is 3 centimeter, B is 2 centimeter. So let's place down these value. Let us place down this value. So kitna ho gaya? 1 upon A is 3 centimeter. Achha, don't forget to convert into meter. Plus 1 by B whole square, and B is 2 into 10 power minus 2. So 1 by B whole square. Okay. So what is going to be the cutoff frequency? Okay. Let's just calculate the numbers and get hold of this. .755 and 3.76 gigahertz. So correct answer, option number A. Some approximations will be there. 3.75. So the nearest option that I am able to match is 3.68. Right. Good evening, Vanya. Okay, 3.68 is the nearest option that you are able to match here. 3.68. Right, dear students? 3.68. Okay, hi, good evening. Chalo, let's move ahead. Okay, I hope the calculations and all are perfect. Yeah, एक बार और check कर लेंगे. Yes, 3.76. Okay, approximately that works fine. Okay, good evening. Just keep on checking the calculations and rest is fine. Now, ये तो हो गया general frequency formula. अच्छा, one more thing let me add on here. Right, when we want to talk about TEMN mode, When we want to talk about TEMN mode, what is the lowest possible TEMN mode? Lowest configuration, lowest order TEMN mode, right? Lowest order TEMN mode, right? What is M and N? They both can't be 0. They both can't be 0. So what is the lowest order? They both can't be 0 together, right? So maybe M is 0 or maybe N is 0, but TE00 does not exist. TE00, this is not a possible mode. When I want to talk about TEMN, in the TEMN, either M or N cannot be 0. None of them can be 0 individually also, right? M cannot be 0, N cannot be 0. So TM11 is the lowest order. It is the lowest order TM mode. Lowest order TM mode. Okay. Okay. Acha, some more important formulas for general case. If it is TEM0, TE mein anyone can be 0, na? The cutoff frequency will be U dash by 2 under root of M by A whole square. The under root square getting cancelled. TE0N, suppose it is only 0N. So cutoff frequency U dash by 2 into N by B whole square ka under root square getting cancelled. Now, what is the dominant mode? In rectangular waveguides, what is the dominant mode? Dominant mode का मतलब क्या होता है dear? Dominant mode is the mode having the lowest cutoff frequency. Dominant mode is the mode with the lowest cutoff frequency, and dominant mode here is TE10. The mode with the lowest cutoff frequency is the TE10. Okay, for rectangular waveguides, and the cutoff frequency is hence given by U dash by 2 TEM0. So M ka value 1, U dash by 2 into 1 by A. Or simply you can write U dash by 2A. Many questions can only be on dominant mode, so U dash by 2A is the direct formula you can apply. Right? Chalo. Now let's go at the next question and keep revising the things. Similar data. Now they're only asking the phase velocity. Now what is the formula for phase velocity inside the waveguides? What is the formula for phase velocity inside the waveguides? Okay. Yes, Karan Gupta. Okay. What is the phase velocity formula inside the waveguides? The phase velocity inside the waveguide is given by the formula U dash is whole divided by under root of 1 minus Fc by F whole square. That is the formula actually. U dash upon under root of 1 minus Fc by F whole square. So let's just calculate this number. How much will be the Vp coming up here? Vp is equal to U dash. U dash is the 1.25 10 power 8 already calculated. It is a continuation of the previous question divided by. Now see, if it is an individual question, what you are supposed to do? Suppose guys, if this was an individual question, then what you are required to do? Then you have to calculate Fc. You have to calculate U dash as we have done in the previous question. Okay, but it is a continuation of previous question, so I have just taken the value. So FC was calculated as 3.75 divided by F kitna hai? 20. F is the given operating frequency, which is 20 gigahertz. Okay, so giga will get cancelled. There is no issue regarding to it. So this is turning out to be nearly 1.27 10 power 8. 1.27 10 raised to the power 8. 1.24 approximately answers match hoga. It's going to be matching approximately only 1.24 10 raised to the power 8. Okay. Right. 1.24 10 power 8. Okay. Definitely Bhavya. Likes for mechanical also, no doubt. Okay. Chalo, done. Next question ready for you. In an air-filled rectangular waveguide, the cutoff frequency. Now the different question. Cutoff frequency of TE10 mode 5 GHz, TE01 mode 12 gigahertz. What is the dimensions of the guide? Guys, simple question. TE10 पे आ जाए. Cutoff frequency is given by the formula. Air filled है. अरे sorry, this is a typo error. Why this typo error have come? ये देखना पड़ेगा. Just wait a second. I want to mention here air filled. Now because this is air filled, so what is the dielectric? Inside is air, and what is the speed of any wave in the open dielectric, which is open air? That is c, 3 into 10 power 8. So directly, what is the cutoff frequency? C. The cutoff frequency C by 2a, dominant mode. Okay, C by 2a, and this is given to you as 5 gigahertz, right? This is given to you as 5 gigahertz. So यहाँ से A निकाल लेंगे. A कितना हुआ? 3 into 10 power 8 divide by 2 and 5 gigahertz. 5 into 10 power 9. Right. So this is 1.5 divide by 5, 0.3 into 10 raised to the power minus 1. So 0.03 meter, or I can say 3 centimeter. So A should be the 3 centimeter. Right. A should be the 3 centimeter. Right. Okay. Now, if I want to talk about TE01, cutoff frequency is C by 2B. TE01 U dash by 2 into 1 by B. So this is C by 2B, and this is given to you as 12 gigahertz. 12 gigahertz. So what is going to be the value for B? 3 into 10 power 8 divide by 2 into 12 gigahertz. 12 into 10 power 9. So this is 0.0125. Yeah, finally solving 1.25 centimeter. Correct? 1.25 centimeter is the answer. Okay, now commonly you specify whether it is 3 cross 1.25 or 1.25 cross 3. Commonly we specify the waveguide dimensions as A cross B. A cross B. So 3 centimeter cross 1.25 centimeter. We specify it in the format commonly as A cross B by default. So it is 3 centimeter cross 1.25 centimeter is the answer. Next question. In an air-filled 5 centimeter cross 2 centimeter waveguide has Ez as equal to 20 sine 40 pi x sine 50 pi by e power minus j beta z volt per meter. Assume that the waveguide is operating at 15 gigahertz. What is the mode being propagated? What is the mode being propagated? So in the see, you are never expected to remember the complete field equations for the waveguide, but at least one thing in the field equation, the coefficient of x is given by the formula kx, which is m pi by a, right? And here the coefficient of y, you don't have to remember any field equation, but you just have to remember that in any of the field equation, coefficient of x and y, and the coefficient of y is ky, that is n pi divided by b. Okay, now with this you can find the value of m and n. With this you can find the value of m and n, and you have to also decide whether it is TE or TM. You have to also decide whether it is the TE or TM. You have to also decide whether it is the TE or TM, dear. Let me just... yeah, whether it is the TE or TM, ये भी आपको decide करके चलना है. Come on, tell me quickly. Okay, chalo, cool. Virtual calculator, dark lord. Virtual calculators are allowed. So guys, if you have calculated this, let us see what is the mode you are getting. What is the mode you are getting? M pi by a. M pi by a कितना है? 40 pi. Right. M pi by a is given by the 40 pi. Okay. So what is the value of, what is, this is 5 cross 2. Larger one is 5. Broader one is 2. B. Okay, larger one and smaller one is B, the narrower one is B. Okay, so M pi से pi cancel हुआ, M is equal to 40 multiplied by A is 5 centimeter, so M का value 2 हुआ. Similarly, N pi by B, this is 50 pi, pi to pi cancel, N is equal to 50, B का value है 2 centimeter. Okay, so this becomes 1, so it is 2 1, M और N का value आ गया 2 and 1, but whether it is TE or TM, now देखो, this is suggesting that e power minus j beta z suggests that what is the DOP of the wave? It is a function of minus z, so wave is traveling in plus z direction. What is the DOP of the wave? This is AZ. Okay, DOP of the wave is AZ, right? And electric field is given to in the z direction. There is one of the component of electric field which is given in the z direction. EZS does not equal to 0. There is one component of electric field in the z direction that is non-zero. So electric field is present along the DOP. Electric field is not transverse to the DOP. Transverse means perpendicular. So electric field is along the DOP, right? It is along the DOP. So it cannot be TM, right? This sees that this mode is not the TE mode. This is not the TE mode because transverse electric mode says that electric field should be transverse, perpendicular to the DOP. Here it is not perpendicular, right? So what is the answer then? Answer is a TM mode with what values? 2 1. Calculation से 2 1 आया, तो TM 2 1 is the answer, dear. Option number A. So whether it is TM 2 1 or TE 2 1, that also we have to identify. TM 2 1, TE 2 1. TM 2 1 or TE 2 1. Right. So it is TM 2 1. ठीक है dear? Chalo. Next question. Now this is a gate intentionally. See, in this series mostly we are not taking the gate questions, but one or two we take on, no problem. So let's take this gate question because this is a very good question. This is a very good question to be discussed. The magnetic field along the propagation direction is given to you. Magnetic field is given along the propagation direction. Okay, first of all यहाँ पे मेरे को clearly दिख जा रहा है what is the propagation direction? Omega t minus beta z. Okay, suggests that the wave is traveling in z direction and hz is not equal to 0. Hz given है, the magnetic field along the z is given. That is very much clear कि it cannot be a TM mode. Here the magnetic field is not transverse to the direction of propagation of wave, so it has to be TE. Okay, now again cos of kxx, cos of kyy, which you can use the calculate. If there is TE mode, what is TE? Mn. What is the value of M or N? That we can obtain from this. Phase velocity of the wave inside the waveguide satisfies how much? Phase velocity of the wave inside the waveguide satisfies how much? अब देखते हैं. Phase velocity of the waveguide inside. Phase velocity of the wave inside the waveguide satisfies how much? I'll tell you one simple result here. See guys, what is the phase velocity formula? We have just now listened. Phase velocity is given by u dash upon under root 1 minus fc by f whole square. इस पे हमने question भी solve किया था. We have solved the questions also based on this. And also let me tell you Vp, let's in general call it as UP. Let me tell you that UP is always greater than U dash. If there is an air-filled waveguide, UP is greater than C because U dash का value C होगा. For an air-filled waveguide, UP is greater than the C. How much? UP is greater than the value of C. The velocity of wave inside the waveguide is always greater than the speed of light. If I talk about air-filled, that is always greater than. Okay, so can I say that A is the correct answer here? So there is a small catch in the question. That is why I've taken this. Otherwise we are taking fresh questions, but one gate question intentionally to discuss very good question. So देखो, let's take up this particular coefficient and this particular coefficient. So we have m pi by A is given by 2.094 into 10 square. So what is the value of m? 2.094 into 10 square into A. Now, what should be A? The broader one is A and the narrower direction is the B. So, A is 3 centimeter divided by pi. Okay, then n pi by b, calculations एक साथ करेंगे. N pi by b, this is 2.618 into 10 square. So, what is n? 2.618 into 10 square is divided by the value of pi. Is divided by the value of pi. Okay. Oh, sorry, into B. B was 1.2 centimeter. So this is 1. This is nearly 1, and the above one this is nearly 2. This is nearly 2. So what is the mode being propagated? Now I can say what is the mode that is being propagated. It is TE already concluded, but with what value of Mn? 21. So this is TE21. This is TE21. Now I want the cutoff frequency to be calculated. Understand the entire concept of the question. अब cutoff frequency पे आएंगे. If it is TE21, what is the cutoff frequency? If it is the TE21, what is the cutoff frequency? Cutoff frequency air filled है ना? Yeah, nothing is mentioned. Air filled ही लेंगे. So it is going to be C by 2. It is going to be C by 2 root over of 2 by A whole square plus 1 by B whole square. So that is 3 into 10 raised to the power 8 divided by 2 under root of 2 by A. A is 3 centimeter plus 1 by B, and B is 1.2 centimeter. Let us just calculate these numbers. This is nearly 16 gigahertz. What is the operating frequency? This will decide the omega. Omega is given to you 6.283 into 10 power 10. So what is the frequency? Omega by 2 pi divide by 2 pi. This is nearly 2 pi cancel. Okay, so this is 10 power 10, or that is 10 gigahertz. Operating frequency is 10 gigahertz, dear. Now, operating frequency is 10 gigahertz. That is less than the cutoff frequency, because cutoff frequency is 16 gigahertz, and whenever for any wave operating frequency is less than the cutoff frequency, it signifies no propagation. It signifies the attenuation mode, right? The very first question we discussed. So it signifies no propagation, dear. It signifies no propagation. There cannot be any propagation, right? And since there is no propagation, what is the velocity of the wave? Since it is not propagating, I will tick mark 0 as the option. Very easy question to be misguide many of the students, because this is a, when you study waveguides and as a theory, as a basic class, you are always taught VP is greater than C. You are always taught VP greater than C, right? So what is the correct statement that we should put down? Right, what is the correct statement that we should put down? That yes, this VP is greater than C. Okay, yeah, ऐसा लिख देते हैं इसको. For any wave which is propagating inside the waveguide, UP or VP is greater than C. If it is propagating, important one here is if it is propagating. If it is not propagating, then the answer is of course 0. Then the answer is of course 0. ठीक है. अच्छा, we have seen, let me just give you quick updates. We have seen the cutoff frequency formula as of now. We have seen the phase velocity formula. Okay, now let me tell you the group velocity formula also. We have seen the phase velocity formula. Now group velocity formula, it is given by U dash under root 1 minus FC by F whole square. So there is one more result, UP into UG is u dash square. इस पे भी question रह चुका है gate पे, right? Then let me give you the wavelength formula, lambda g, right? And that is given by lambda dash divided by under root 1 minus fc by f whole square, right? Beta formula, phase constant, that is beta dash under root 1 minus fc by f whole square. Okay, let me again tell you what is lambda dash. Lambda dash means the wavelength formula in the open dielectrics, which you all know, C by F, right? C by F or U dash by F. C if it is air filled, otherwise U dash by F. What is beta dash? Beta dash means the beta formula in the open dielectric medium, and that is omega root over mu epsilon. That is omega root over mu epsilon. The basic formula of beta, which you have studied with the wave propagation also. Okay, one more thing is left. That is the intrinsic impedance. Okay, so intrinsic impedance, if it is a TE wave, then it is eta dash upon under root of 1 minus fc by f whole square. If it is TM, intrinsic impedance will depend whether it is TE or TM mode. If it is TM, eta dash multiplied by under root 1 minus fc by f whole square, right? So that eta TE and eta TM, it is eta dash square. Acha, what is eta dash once again? What is eta dash once again? Eta dash is the same intrinsic impedance formula which you will use if there was an open dielectric lossless medium. So that is given by the formula root over mu by epsilon. And all these formula we have revised in the wave propagation YouTube class just 2 days back. Okay. So list of all the formula, whatever question is coming, it is out of this. 99% of the questions is coming out of this. Some different questions also I'll try to show you. Okay. And one important thing, when you go to circular waveguide, listen, when you go to circular waveguide, cutoff frequency formula will be something else. But the good thing is with circular waveguide, all these formulas are same. Right, all these formulas are same. Okay, cutoff frequency formula I will tell you, but rest all the formulas will remain to be same. Okay, will remain to be exactly same. So that is the good point you must remember. Consider a 150 meter long air filled hollow rectangular waveguide with cutoff frequency given to you 0.5 gigahertz. Now a short pulse of 7.2 gigahertz is introduced at the input of the guide. What is the time taken by the pulse to return to the input end? This is a good decent question as a homework. Time taken bola hai, so time is always given by distance is divided by speed. You have to calculate speed by the formulas we have discussed, and distance is given to you. Okay, now to return to the input end, time taken to return to the input end, to see what distance you have to put, length of the waveguide is given to you, right? And speed you have to calculate just by the formula we have discussed. Simple hai, because cutoff frequency is also given. Otherwise we need to calculate cutoff frequency, but here the cutoff frequency is also given. So it is simpler only, I can say. Correct? It is simpler only. Cutoff frequency given it here. Okay. So not much of the calculations will be involved. So you can take this as a homework. You can definitely take this question as homework. Chalo. Now, next important question. Range of frequency for which single mode operation will occur. Single mode operation will occur. A 4 cm cross 6 cm rectangular waveguide is filled with a dielectric of refractive index 1.25. अब देखो यहाँ पे जो refractive index है वो given है. Refractive index is given by the formula under root of mu r epsilon r. It is the geometric mean of relative permeability and relative permittivity. Okay, since we assume it to be dielectric medium, so we'll take mu r equal to 1. Right, so under root of 1 into epsilon r is 1.25. So epsilon r is the square of 1.25. Okay, so that is what refractive index basic formula. It is the geometric mean of epsilon r and mu r. Okay, so this is 1.5625. 1.5625. Okay, तो ये तो हो गया epsilon r. Now because of this epsilon r we can calculate the speed. अच्छा, इसका epsilon r का need भी नहीं है. Forget. No need to calculate epsilon r. Okay, I'll just write down in front of you. N is given by the formula root over mu r epsilon r. But what is the basic meaning of n? Sorry, that calculation is actually not required. What is the basic meaning of the refractive index? Refractive index of a material, of a medium, is equal to the speed of the light in free space, speed of the wave in free space, that is c, divided by the speed of wave in that particular medium. Okay, and that we call it as u dash here. So what is the value of u dash? That is 3 into 10 raised to the power 8 divide by 1.25 divide by the 1.25, right? 2.4. So u dash is 2.4 into 10 power 8. So no need to calculate epsilon r. Okay, this is the direct basic definition of refractive index I have used. Okay, this is also the basic definition of the refractive index. Chalo, now range of frequency for single mode operation I'll explain you, but what is the mode having the lowest cutoff frequency? Dominant mode. What is the dominant mode for rectangular waveguide? TE10. So let's start with the dominant. TE10. What should be the cutoff frequency formula? Sir, it is u dash by 2a. Place down the value. 2.4 10 power 8 divide by 2a. What is a? A stands out to be 6, b stands out to be 4. So a is 6 centimeter. Okay, let's calculate and get the answer. Divided by 2 6 are 12, and then it is into 10, 2 gigahertz. This should be the 2 gigahertz. Now, if I next, what could be the next cutoff frequency? It may be TE20 or TE01. That we have to really calculate. Depends on the A and B value. TE01 dekhte hain, chalo. TE01. Right. Cutoff frequency. Right. TE01. So U dash by 2B. U dash by 2 into 1 by B. TE0N formula. So this is 2.4. 10 की power 8 divided by 2 into B, and B कितना है? Let me check out once. That is 4 centimeter. This is going to turn out to be 3 gigahertz. Okay, this is going to be turned out as 3 gigahertz. Right? Okay, this is 3 gigahertz. Next, let me try TE20 now. If I take TE20, the cutoff frequency is U dash by 2 into 2 by A, or U dash by 2A multiplied by 2. So that is 2 gigahertz into 2. This one is 4 gigahertz. Okay, and etc, etc, etc. So if I show you these particular points on the frequency scale, to see what is going to happen. Suppose this is the frequency in gigahertz. Okay, dear, let us all say this is the frequency in gigahertz. This is 2 gigahertz, then comes 3 gigahertz, then come 4 gigahertz, and then etc. Right? If there is any wave having the frequency less than 2 gigahertz, there will not be any propagation. There will not be any propagation. No mode can propagate here. But if you take any frequency which is greater than 2 gigahertz, greater than the cutoff frequency, so propagation is possible. In which mode? TE10. But TE01 se abhi bhi kam ho, so TE01 mode will not come. Right? So here TE10 mode can propagate. When you take between 3 to 4, now you have crossed the 3. If it is greater than 3, it is greater than 2 also. So still TE10 will be possible. TE01 will also be possible. TE10 and TE01. If you take little more than that, so TE0 to be after, if you go 4, if you just go greater than 4, TE20 will also come. TE20 will also come. So the numbers will keep on increasing. Okay. What is the range of frequency for single mode? So single mode exists here. Okay, for the frequency range of 2 to 3 gigahertz. For the frequency range of 2 gigahertz to 3 gigahertz, the single mode operation will be there. For the frequency range of 2 gigahertz to the 3 gigahertz, single mode operation will be there. For the frequency range of 2 gigahertz up to the 3 gigahertz, frequency range will be there. Single mode operation will be there. Right, guys? Single mode operation will be there. Correct? Yes, Dreamer, correct answer. It is 2 gigahertz to 3 gigahertz. That is option number B. That is what is meant by the single mode operation. Okay? Chalo. Next. This is done. What is the dominant mode in circular waveguide? What is known as the dominant mode in circular waveguide? What is known as the dominant mode in circular waveguides? Tell me, dear. Dominant mode in circular waveguides. Dominant mode, circular waveguide. इन सर्कुलर वेवगाइड, रेक्टेंगुलर की बात नहीं कर रहे. रेक्टेंगुलर में तो ऑलरेडी वी हैव स्टडीड. डोमिनेंट मोड इज TE10. इन द केस ऑफ सर्कुलर वेवगाइड, द डोमिनेंट मोड इज TE11. TE11 mode having the lowest cutoff frequency. Mode having the lowest cutoff frequency. Mode having the lowest cutoff frequency. TM10 mode in circular waveguide is. Now see, this is, I just want you to see how much you are able to revise with respect to circular waveguide. TM10, whether it is evanescent, propagating, non-existing or dominant. Dominant तो नहीं है ये. Dominant already I told you it is TE11. Right? Tell me the answer. Just a second, guys. Yeah, let me see what is the options given to you. Existing and propagating mode, I have not revised it yet. Okay, Gajendra, chalo, I'll tell you. Manasvi says A, evanescent. Janvi says C. Dekho, what is the difference? First of all, make it clear. What is the meaning of propagating mode? Propagating mode, as just explained you in the previous questions also. A mode is propagating. Suppose let's take the previous rectangular waveguide question. Okay. If I take the frequency in the range 2 to 3 gigahertz, the TE10 mode is said to be propagating. If I take the frequency less than 2 gigahertz, TE10 is said to be evanescent. Evanescent means a mode which just dies away. Because of what? Because of attenuation. The wave does not propagate because of attenuation. So if you take any frequency less than 2 gigahertz, the TE10 or even all other modes, okay, will be evanescent modes. Okay, so whether it is evanescent or propagating, that depends on the operating frequency and its relation with the cutoff frequency. Sir, यहाँ पे तो कुछ given ही नहीं है. Evanescent will be F less than FC, and these are the 2 points already I explained you. Now, what is non-existing or existing? देखो, like I told you for rectangular waveguides, is there any TE00 mode? Rectangular waveguides, is there any TE00 mode? There cannot be TE00 mode, na? There cannot be TE00 mode. There cannot be it is not at all possible. Propagation or evanescent, it is a different thing. I told you M or N both can't be 0. It could be 10, it could be 01, but TE00 mode cannot exist. Is not possible. That is non-existing. Okay. So similarly, in the circular waveguides also, you have TENP or TMNP modes. You have TENP or the TMNP modes, right? Where N can take. Okay, TE10 क्या होगा वो बताना है यहाँ पे, right? TENP or TEMP. P cannot be 0 actually. यहाँ पे p का वैल्यू इनने 0 दे दिया है एंड p एक्चुअली कैन नॉट बी 0. p actually cannot be 0. There can be TEN0. There cannot be TEN0. There can be TE0P. Right? अभी इस पे क्वेश्चन भी देखेंगे हम आगे. Right? Okay. For example, I'll have a question coming up. Where is that question? I think it is straight after long time. चलो forget that question. आओ बाद में आएगा काफी. So p cannot be 0. Rest m and n and p can take any value, right? So TEN0, or if you want to take TMN0, they do not exist. They are known as non-existing. So option number C. I hope now you are clear with the difference of non-existing and evanescent. What is a non-existing mode? Which is not at all possible. But what is an evanescent mode? A mode which is possible, but it does not propagate. It is attenuated because of f less than fc. Because of the f less than fc. ठीक है? अच्छा, now what is that cutoff frequency formula for the circular waveguide, dear? See, whether it is the TENP or TMNP modes, what is the cutoff frequency? The cutoff frequency is given by the formula KCU dash by 2 pi, right? KCU dash by 2 pi, U dash has the same meaning as always, and KC is given by the formula X dash NP divided by A. So this can also be written as X dash NP U dash divided by the 2 pi A. Right? Where A is known as the radius of the circular waveguide. Okay, and X dash NP is known as the solution of Jn dash X equal to 0. Jn dash is known as the derivative of Bessel's function. Now, do you need to solve Bessel's function in the exam? No, you can't. Okay, so what about this value? X dash NP? This will be given with the question if the data is required. Okay, X dash NP, I will show you the questions also. X dash NP has to be a given data in the questions. X dash NP has to be a given data in the question. Only tip from my side is remember the X dash NP only and only for dominant, because dominant is the most important question, na? Remember it for the dominant mode. What is the dominant mode? TE11, right? X dash 11 for the TE11 is given by 1.841. Rest if required. See, most likely this will also be given in the question, but just as a suggestion on a safer side, just remember that X dash NP value for the dominant mode. ठीक है, चलो. अच्छा, ये तो हो गया कट ऑफ फ्रीक्वेंसी का फॉर्मूला. So what I have told you the cutoff frequency formula. Okay, let me write down once again. KC U dash by 2 pi or X dash NP U dash by 2 pi A, where A is the wave radius and X dash will be given in the question. Rest, what is the formula for VP? What is the formula for VG? Group velocity, phase velocity, guided wavelength, beta formula, intrinsic impedance for TE, intrinsic impedance for TM. Guys, let me tell you one simple thing. All these formulas, one important point for you is all these formulas are similar to that of rectangular waveguide. This eases out your study. Circular waveguide, rest all these formulas are similar to rectangular waveguide. Now a question, air-filled circular waveguide, air-filled है तो U dash का value C लेते हैं. Okay, 6 centimeter diameter, so A becomes 3 centimeter because A means we want the radius, the radius becomes 3. Dominant mode we know TE11, right? So what is the X dash 11? That is a value 1.841. Determine the cutoff frequency. Okay, so I will do it very quickly. Cutoff frequency, as I told you, X dash 11 U dash divided by 2 pi A. So 1.841 multiplied by U dash, which is C, 3 into 10 power 8, divided by 2 pi A. A is the radius 3 centimeter. 2.93 gigahertz. Okay, no Gajendra, no. Only TE and TM, right? 2.93 gigahertz. 2.93 gigahertz. Transmission lines will make you allow that. Right? Not the perfect circular waveguides, Gajendra. Okay, so 2.93. This question is solved. Next question. Same data hai. The same question. I'll just put it as numbers. So on the same data, this is the question number 1. Cutoff frequency. Question number 2 क्या बोला है? Wavelength inside the guide. That is the question number 2. Right. So question number 2. Wavelength inside the guide. Lambda g. What is the formula I told you for lambda g? It is given by the formula lambda dash upon under root 1 minus fc by f whole square. The guided wavelength. Wavelength inside the guide. That is the formula. Same as rectangular waveguide. And what is the values now? What are the values? देख लेते हैं. Lambda dash is u dash by f. U dash is same as previous question, 3 into 10 power 8. Frequency, operating frequency of 4 gigahertz is given. So 4 into 10 power 9. So this is 0.075 meters or 7.5 centimeter. So what is going to be the lambda g? 0.075 divided by the under root of 1 minus fc. Cutoff frequency 2.93 calculated. Divided by operating frequency 4 gigahertz. Gigahertz anyway is getting cancelled. Okay. Point 0.11 meters. Just check out the calculation once. 0.11 meters. 0.11 meters. Next question on the same data. Next question. Wave impedance. Question number 3. Okay, rest all the data is same. Okay, but which mode is given? Okay, they are asking the intrinsic impedance. But intrinsic impedance, what is the mode they are talking about? Dominant mode. Okay, dominant mode is TE11, right? TE11. So what is the eta formula you need to use is eta TE, and eta TE is given by the formula eta dash upon under root 1 minus fc by f whole square. If it was TM, then you have to use the other formula. Okay. Chalo. Now what is the eta dash? Eta dash. Now because it is air filled, ना यहीं पे mention कर देते हैं. Since it is air filled, eta dash will be eta naught. What is the wave impedance of wave inside air? And that is the value of 120 pi or 377 ohms. Okay. So yeah, just let's put down the values and go for the answer. That is 377 upon under root of 1 minus 2.93 divided by 4 whole square. Answer should be 553.78 ohms. 553.78 ohms. Wave impedance 553.78 ohms, right? Chalo. Yes guys, do not forget to like the session, mark your attendance, show your motivation, show your love towards the BYJU'S Exam Prep YouTube English channel. For all such events, we are making it possible for you. Now again, same data and one more question. Phase velocity, Q4. So kindly take down this one question as the homework. This is the next homework for tonight, because phase velocity, as solved earlier also, will be solved by the formula u dash upon under root 1 minus fc by f whole square. Same formula, na? Same formula. U dash upon under root 1 minus fc by f whole square. Correct. Chalo, just one line calculation, but thoda sa efforts kar lena. That is given to you as homework. Next question. Okay, dominant mode, same. The last question, propagation constant here. Propagation. This is the last question on the same data. Acha, propagation constant means they want to ask gamma, and gamma is j beta. गामा इज जे बीटा लॉसलेस डाइलेक्ट्रिक्स के अंदर, राइट. एयर फील्ड है ये, एयर इज लॉसलेस मीडियम, राइट. एंड व्हाट इज द बीटा फॉर्मूला देन? What is the beta formula? As I already told you, beta dash under root 1 minus fc by f whole square. So let us first calculate the beta dash. Beta dash is nothing, omega root over mu epsilon, or we can also write it as omega by u dash, right? What is the omega? 2 pi f. What is the operating frequency? 4 gigahertz divided by u dash, that is air filled. So speed of light 3 into 10 power 8. How much is this calculation? Okay, this is 83.77 or 83.78. This is the beta dash. So what is going to be the final beta? 83.78 under root 1 minus fc by f whole square, that is 2.93 divided by 4 whole square. So 56.96. Beta should turn out to be 56.96 radian per meter. Okay, so that the final propagation constant, which is j beta, and that will be j 56.96, right? The unit of propagation constant is per meter. The unit of propagation constant is per meter. Okay, gamma is j beta. Chalo, perfect. Next question. An air-filled circular waveguide. An air-filled circular waveguide of 2 cm inner radius. A का value 2 है, air-filled है, तो once again U dash will be taken as C. It is operated in TE101. Now, TE01. ध्यान देना. It is not dominant now. And that is why this question must specify the Bessel derivative solution. That is x dash np, and they have specified, otherwise you will not be given such question or you can't solve it up. Okay, compute the cutoff frequency. Okay, so what is the cutoff frequency? It is x dash np u dash divide by 2 pi a. X dash np given hai 3.832 for the given mode. U dash is 3 into 10 power 8 because of air filled condition, divided by 2 pi a. A is equal to 2 centimeter, 2 into 10 power minus 2. It is a 2 centimeter as 2 into 10 raised to the power minus 2. Okay. .15. Guys, simple answer. 9.15 gigahertz. 9.15 gigahertz is the correct answer. 9.15 gigahertz is the correct answer. Okay, now good one. ISRO question I am discussing here. It's a good question. It's a good question. Comparing a rectangular and circular waveguide. Consider a standard rectangular and circular waveguide having the same dominant cutoff frequency. Okay, what is the standard rectangular? It will be used, I will specify, same dominant cutoff frequency. Rectangular waveguide, what is the dominant mode? Dominant is TE10. And what is the cutoff frequency? Achha, let's say the rectangular waveguide is having the dimension A cross B, and cutoff frequency will be U dash by 2A for the dominant mode. Okay. What is circular waveguide? And what is the dominant mode in circular waveguide? Dominant mode in circular waveguide, as we have discussed, it is TE11. And what is the cutoff frequency? It is given by x dash np, yeah, x dash 11 u dash divide by 2 pi a, right? What is, now a, let's not use a here. Okay, let's use r here, right? Where r is equal to radius. Okay, because a is the dimension of the rectangular waveguide I have used. So let us avoid that a. Let us say r is the radius. Name is anything. Name, naam mein kuch nahi dekha. You can take any name. Okay. Now these two are equal. They have the same dominant cutoff frequency. Okay. So what is given to you is, acha, if I complete this value na, x dash 11 dominant ke liye I know the value na, 1.841 u dash divided by 2 pi r. Okay, so what is given to you? U dash by 2a, the first, this one cutoff frequency should be equal to 1.841 u dash is divided by 2 pi r. Correct? Is divided by 2 pi r. Now, what is the ratio of the area of circular waveguide to that of rectangular waveguide? Okay, यहाँ से पहले r by a निकाल लीजिए. Bring r on the left hand side. 2 cancelled. U dash cancel. 1.841 divided by pi. 1.841 divided by. Ratio of the area of circular waveguide to that of the rectangular waveguide. Circular waveguide area should be pi r square cross sectional area. Rectangular waveguide area should be a cross b. Rectangle area is base into height, but I don't know b. A is somehow coming. Now I have to use this point. What is the standard rectangular waveguide? Okay, having standard rectangular waveguide is one which has the ideal aspect ratio. Which has the, I told you what is the ideal aspect ratio? It is the one having the ideal aspect ratio A is to B is 2:1. A is to B is 2:1. Okay. So what is the A by B is 2:1. So what is the B you can use is A by 2. Let us put in terms of A. Let us put this in terms of A and complete the answer. So this becomes pi r square upon A into A by 2. Right. So 2 goes above 2 pi r by A whole squared. So this is 2 pi r by a, I know 1.841 divide by pi whole squared. So देखो one of the pi will be cancelled. Now 1.8 square approximately, ISRO question है ना, without calculator will solve. 1.8 कहाँ गया? Right, this is approximately 2 pi 1.8 upon pi, approx कर दिया, because 1.8 का square I know, 18 square is 324, right? So 1.8 3.24 multiply by 2, 3.24 multiply by 2, so 6.48. Pi square and pi, one of the pi is cancelled, so 6.48 divided by pi, 6.48 divided by pi. Now that is approx. I have just reduced the number little bit, na? Okay, it is 1.841, thoda sa bada hoga. 6.48 divided by pi, little greater than that, option number B. A very good question. Now see, this is our exact word-to-word ISRO question. They have used the dominant mode of circular waveguide and they have not given you this value. That is why I told you as a tip, remember the X-11 for only dominant mode, not any other. Any other is not expected because otherwise the list is endless. Okay, but this value is expected. Otherwise this question also becomes blank for us. Okay. So remember the X-11 especially for the dominant mode, dear. Correct? Especially for the dominant mode. Chalo. Okay. That's it, guys. This is it for the waveguide questions from my side. Next session will be antenna, and before that a mega workshop on the BYJU'S Exam Prep app tomorrow. A final reminder, because tomorrow 12:30 p.m. I am coming live on the app. Download the app if you don't have it. It's available on Google Play Store. Download and register for this mega workshop where we are going to talk about strategy to secure AIR under 100 in GATE 24. Little bit more push you give. For you, it can be AIR under 10, single digit ranker as well, right? Join me live on the app tomorrow at 12:30 p.m. With this, I sign off. Next session will be based on antenna and yes. Password क्या होगा आज का? Password क्या बताएंगे? Let's make it as RWG. Today's password, rectangular waveguide, RWG, all capital today. Note down this password, RWG, all capital. Today's password, RWG. PDF will be shared in the Telegram as I have shared for the previous 3-4 sessions as well, whichever I have conducted, and the password is RWG, rectangular waveguide. Rectangular waveguide, RWG, capital. Okay, see you in the another session. Tomorrow is anyway Sunday, you don't have any session. Okay, see you in the next session. That is again extreme important, antennas. That is going to be very important, antenna. Almost a surety question from antenna. Okay, Okay, with this I'll sign off. Bye bye. Thank you. Stay safe and do take care of yourself.